Okay, so as Brian said, my name is Julián Duque, will be in proper Spanish. I come from a very beautiful town in Colombia called Medellin. So if you haven't gone there, please visit us, that we have like an amazing community, as Brian said. Right now I work as a senior developer advocate for Heroku. So I live in the United States. Sadly, I'm kind of away from my country, but I always constantly in communication with my community, and that's pretty much through two main conferences that I organize. One is the NodeConf Colombia, and the other is the JSConf Colombia. So I know if you were like me right now, you are needing coffee. I'm needing coffee too. It's super early. So please don't crash now. Let's wait until my talk finish, and we can like have some coffee to keep us awake. So a little bit of some background about this talk, or why I presented this. These are pretty much lessons learned while I was working at NodeSource previously. I was doing like consulting work as a solutions architect, visiting the customer, making sure they were using Node.js properly and they were successfully using Node. And I saw a lot of different bad patterns out there on how other companies were doing error handling, and especially when the process were crashing or the process were dying. They didn't have enough visibility. They didn't have like login strategies in place. They were like missing the very important information about why the node processes were having issues or were crashing. They were experiencing downtime, and we started like to collecting a set of best practices and recommendations for them that are aligned with the overall Node.js community. If you go to the documentation, there are going to be pretty much the same recommendations that I'm going to be speaking about today, with a couple other more things to make sure you have like a very good exit strategy for your Node.js processes. These best practices applies pretty much for web and network-based applications, because we are going to cover also the graceful shutdowns, but you can use them for other type of Node.js applications that are constantly running. And no, sadly, is not the Erlang way. If you know about Erlang or Elixir, the let it crash is just like a term that is very common in that community. When I started learning Erlang back in 2014, I loved the fault tolerance options that this platform and language has. And I always think about how to bring the same experience into Node.js. Is not the same, because you can do whole code reloading or function swapping on Node. You can do those things on Erlang, but still, Node is pretty lightweight, and you can like easily restart and recover from a crash. First, before getting into the bad place or when bad things happen, how to make sure that everything is good. What do we need to do to our Node applications to make sure they are running properly? So first, as a recommendation, and there are going to be a workshop later about this specific thing, Cloud Native JS. Don't miss this workshop by Beth. She's going to also mention about like how to add health checks to your Node.js processes. So pretty much, as a recommendation, add a health check route. It's a simple route that is going to return a 200 status code, and you will need to set something to monitor that route. You can do it at your load balancer level if you are using a reverse proxy or a load balancer like Nginx or HA proxy, or you are using ELB, ALB, any type of application that is being the top layer of your Node.js process, being constantly monitoring that the health check is returning okay, so you are making sure that everything is fine. And also rely on APMs, on tools that are going to monitor the performance and the health of your Node.js processes. So in order to make sure that everything is running fine, you will need to have tools, some like very known tools like New Relic, AppDynamics, Dynatrace, and Solid. There are like a lot of them in the market. Will give you way more visibility around the health of your Node.js processes, and you can like live like in peace when you are like making sure your node is running properly. But what to do if something bad and unexpected happens? So what should we do with our Node.js processes? Letting them crash. So if something bad and unexpected happened, I will let my Node.js process crash. But in order to be able to do it right, we will need to implement a set of best practices and follow some sort of steps to make sure that our application is going to restart properly and continue running and serving to our customers and clients. Before letting it crash, we will need to learn about the process lifecycle, especially on the shutdown side of things, some error handling best practices. There is going to be also another very recommended workshop around it. I'm not going to be covering how to properly handle errors in Node.js, just on shutdown. And this is pretty much so you can stop worrying about unexpected errors and increase visibility of your Node.js processes, increase visibility of what happened when your process crashes and what might be the reason so you can fix it and iterate over your application. So similar to, coming back to the Erlang concept, a Node.js process is very lightweight. It's small in memory. It doesn't have like a very big memory footprint. And the idea is to keep the processes very lean at a startup so they can start like super fast. If you have a lot of operations like high-intensive CPU or synchronous operations at the startup, it might decrease the ability to restart like super fast your Node.js processes. So try to keep your processes very lean on a startup. Use strategies like pre-building, so you are not going to build on a startup or on the bootstrap of your process. Do everything before you are going to start your process. And if something unexpected and bad happens, just exit and start a new Node.js process as soon as possible to avoid downtime. And pretty much this is called a restart. You are letting the process crash and then start a new one. But we will need to have some sort of tools in place and settings to be able to have something that restarts of our Node.js processes. So let's learn how to exit a Node.js process. So there are like two common methods on the process module that will help you to shut down or terminate a Node.js process. The most common one is the process.exit. You can pass an exit code, the 0 if it is a success exit, or higher than 0, commonly 1 if it is a failure. And this pretty much instructs Node.js to end a process with the specified exit code. And there is the other one, which is the process.abort. With the process.abort, it's going to cause Node.js process to exit immediately and generate a core file if your operating system has core dumps enabled. So in order to be able to have like more visibility on post-mortem debugging, to be able to see what happened or what crashed your Node.js process, if there is like a memory issue, you can call process.abort. It will generate a core dump, and then you can use tools like llnode, which is a plugin for LLDB to do like C and C++ debugging of the core dump and to see what might happen in the native side of Node.js when your process crashes. So those are like the two options you have to exit a Node.js process. How to handle exit events? So Node.js emits two different or two main events when your Node.js process is exiting. One is the before exit. So the before exit event, it's a handle that can make asynchronous calls, and the event loop will continue to work until it finishes. So before the process is it's ending, you can schedule more work on the event loop, do more asynchronous tasks, and then you can clean up your process. This event is not emitted on conditions that are causing like explicit termination, like on an uncaughtException or when I explicitly call process.exit. So this is on other exit scenarios. And the exit event, it's a handle, also can't make a synchronous call. Only synchronous calls can happen in this part of the process lifecycle because the event loop doesn't have any more work to do. So the event loop is paused in here, so if you try to do any synchronous calling here, it's not going to be executed. Only synchronous calls can happen here. And this event is emitted when process exit is called explicitly. It's commonly used if you want to log at the end some information when you process exit, like my process exit with this specific exit code, and you want to add some more context around the state of your application at the time that the process exited. Some examples how to use it. You attach those events on the process module. The before exit can do like asynchronous code, so that set timeout. Even though the event loop is paused at that moment, when you schedule more asynchronous work, it will resume the event loop and continue until there is no more work to do. There is one thing I want to mention here is that normally a Node.js process exits when there is no more work scheduled on the event loop. When there is nothing else on the event loop, a process is going to exit. Why a server keeps running? Because it has a handle register on the event loop, like a socket waiting for connections. And that's why a web server is constantly running until you close the server or you interrupt the process. Otherwise, if there is something registered on the event loop, the Node.js process is going to continue running. So in this case, I execute set timeout, schedule more work. It will continue working until there is no more left to do. And process on exit, pretty much just synchronous calls. I can do anything here with the event loop. The event loop is totally paused, useful for logging information or saving the state of the application on exit. There is also a couple of signal events that are going to be useful on shutdown. There is the SIGTERM and SIGINT. SIGTERM, it's normally emitted when a process monitor sends a signal termination to your Node.js process to tell them that there is going to be like a successful way to shut down your process. Like when you execute like on systemd or using upstart, when you send like a stop that service or stop that process, it's going to send a SIGTERM to your Node.js process, and you can handle that event and do some sort of work on that specific part of the lifecycle. And the SIGINT, it's an interruption. It is emitted when you interrupt the Node.js processes. Normally, when you do Control-C, when you're running on the console, you can also capture that event and do some work around it. So these are like two ways to expectedly finalize a Node.js process. So these two events are considered a successful termination. This is why I'm exiting here with the exit code 0, because it is something that is expected. I say I don't want this process to continue running. And there is also the error events. So there are like two main error events. One is the uncaughtException, the infamous uncaughtException. And recently, when promises were introduced into Node, the unhandledRejection. So the uncaughtException is emitted when a JavaScript error is not properly handled. So it pretty much represents a programmer error or represents a bug in your code. If an uncaughtException happens, the recommendation is to always crash your process, let it crash. Don't try to recover from an uncaughtException because it might give you some sort of troubles. And even though the community is not totally agree on the second one, I will say the same for an unhandledRejection. An unhandledRejection, it is emitted when a promise is rejected and there is no handler attached to the promise, so there is no catch attached to the promise. It might represent an operational error, it might represent a programmer error, so it depends of what happened here. But both of those cases, it's better to log as much information as possible, treat those as P1 issues that needs to be fixed in the next iteration or in the next release. So if you don't have any strategy in place to be able to identify why your processes are crashing and you are not fixing and handling those properly, your application are going to remain having bugs. So if it is an uncaughtException, that's a bug, that's a programmer error, that is something that is not expected. Please crash, log, and file an issue, so that needs to be fixed. If it is an unhandledRejection, see if this is like a programmer error or if it is an operational error that needs to be handled. and go update the code, add the proper handling to that promise, and continue with your job. So as I said, in both cases, an error event, it's a cause of termination for your Node.js process. Always exit the process with an exit code different than 0. So it's going to be 1, so your process monitor and your logs know that it was a failure. And as I say, don't try to recover from an uncaught exception. While I was working as a consultant, I saw a lot of people trying to do a lot of magic to avoid the Node.js processes dying by adding some complex logic on the uncaught exception. And that always ended your application on a bad state, or having memory leaks, or having like sockets hanging, and it was kind of a mess. So it's cheaper to let it crash, start a new process from scratch, and continue receiving more requests. So a couple of examples: uncaught exception and unhandled rejection. The uncaught exception receives as an argument an error instance, so you get the information about the error that was thrown and that wasn't handled in your Node.js code. And the unhandled rejection is going to give you a reason, which can be an error instance too, and it will give you the promise that was not properly handled. So those are like useful information that you can have in your logs to have more information where things are failing in your code. But we saw how to handle events, how to handle the errors, some of the best practices, but how to do it properly. What we need to do better to be able to have a very good shutdown strategy for Node.js processes. So the first one is running more than one process at the same time. So rely of horizontally scaling, load balance your web processes, having more than one. So in that way, if one of those processes crashes, there is another process that it's alive and it's able to receive requests. So it will give you time to do the restart, and other requests are coming in, and maybe the only issue you are going to have are with the requests that were already happening in the Node.js process that crashes. But this is going to give you a little bit more leverage and prevent downtime. And what to use for load balancing: use whatever you have in hand. If it's Nginx or HA proxy as a reverse proxy for your Node.js applications. If you are on AWS or on the cloud, you can use their Elastic Load Balancer, application load balancers, or the other load balancer solutions that cloud offers. If you are on Kubernetes, you can use Ingress or other different load balancer strategies for your applications. So pretty much make sure that you have more than one Node.js process running, so you can be more in peace if one of those processes crashes. You will need to have process monitoring. And process monitoring is pretty much something that is running in your operating system or an application that it's constantly checking if your process is alive or not. If it crashes, if there is a failure, the process monitor is in charge of restarting the process. So the recommendation is to always use the native process monitoring that it's available on your operating system. If it's Unix or Linux, you can use systemd or upstart, specifically adding the restart on failure or respawn when you are working on upstart. If you are using containers, use whatever is available. Docker has the restart option. Kubernetes has the restart policy, and you can also configure your processes to restart when it fails, to retry a number of times, so you don't go into like a crazy error that is going to constantly make your application crash and you ended in a crash loop. So you can add like some sort of like retries into there, but always have a process monitoring in place. If you can't use any of these tools, as a last resource, but not recommended, use a Node.js process monitoring like PM2 or Forever. But I will not recommend this to any customer of mine or any friend. But if you don't have any more resource, if you can use the native stuff in your operating system, or if you are not using containers, you can go this way. These tools are good for development, don't get me wrong. If you are like on the development, they're like very good tools to restart your processes when they crashes. But for production, they might not be the best. Let's talk about a little bit graceful shutdown. So we have a web server running. The web server is getting requests, and it's getting connections. And we have some established connections between our customers or our clients and the server. But what happens when the process crashes? When the process crashes, if we are not doing a graceful shutdown, some of those sockets are going to be kept hanging. And they're going to wait until a timeout is being reached. And that might cause downtime and decrease the experience of your users. So it is better to set up an on-reference timeout that is going to let the server do its job. So we will need to close the server, explicitly say to the server, stop receiving connections, so they can reject the new connections. So new connections are going to be going to the new or to the other Node.js process that is running through the load balancer. And it will be able to send a FIN packet, a TCP FIN packet to the clients that are already connected. So they are going to be finishing the connection immediately when the server dies. They are not going to stay waiting until a timeout is reached out. They are going to be closing that connection. And on the next retry, we expect that the process has restarted at that point, or they go to another process that is running. So one example of that on reference timeout, when we are handling the signal or error event, which is the shutdown part of the lifecycle, what we can do is to explicitly call server.close. If it is an instance of the net server, which is the same one that uses the HTTP or HTTPS node modules, you can pass a callback. So when it finishes closing the connection, it will exit the process successfully. But we will need to have a timeout in place because we don't want to wait for a long time. Imagine if we have like a lot of different clients connected, that it's taking a lot of time to clean up those processes. We need to have some sort of way to have an internal timeout. So here, we are scheduling a new timeout, but that timeout is not on the event loop. That last part, the onRef, is not scheduling the timeout on the event loop, so it is not adding more work to the event loop. So when the timeout is reached, or the server close callback is reached, either of those paths are going to close the Node.js process. So this is kind of like a race between the two, between your timeout that is not on the event loop, or between the server close, whichever works better. And what timeout time we do need to put here, depending on the needs of your applications. We had customers that had the need to have like very, very few timeouts or a small timeout because they were like doing a lot of real-time trading and they needed the processes to restart as far as possible. There are others that can have like longer timeouts to let all of the connection finishes. So this depends of the use case. If you don't add the onRef in here, since this timeout is going to be scheduled on the event loop, it's going to wait until it finishes and the process is going to end. So this is like a safeguard, so there is no more work scheduled on the event loop while we are exiting our process. Logging. This is one of the most important parts of having a very good exit strategy for your Node.js processes. So implement a robust logging strategy for your application, especially on shutdown. If an error happens, please log as much information as possible. An error object will contain not only the message or the cause of the error, but it will also contain the stack trace. So if you log the stack trace, you will be able to come back to your code and fix and look specifically why it failed and where it failed. And you can rely on libraries like Pinot or Winston and use transport to store the logs in an external service. You can use like Splunk or Papertrail or use whatever you like to store the logs, but have a way to always go back to the logs search for those uncaughtExceptions and unhandledRejections and being able to identify why your processes are crashing, fix those issues, and continue with your work. So how can we put this all together? I have like some sort of pattern I use on my projects, but there is also a lot of modules on NPM that are going to do the same thing, even better than the approach I'm following here. So this is kind of a pattern I use. I create a module called terminate, or I use like a file called terminate. I pass the server, like the instance of that server that I'm going to be closing, and some configuration options, if I want to enable core dumps or not, and the timeout. Usually, when I want to enable the core dump of Node, I use an environment variable. When I'm going to do like some sort of performance testing on my application, or I want to replicate the error, so I enable the core dumps, I let it crash with the process.abort, I check at the core dump and get more information about it. So here I have an exit function that switches between the abort or the process.exit, depending on the configuration you have here. And the rest, I'm returning a function that returns a function, and that function is the one that I'm going to be using as the exit handler. And this is pretty much the code that I'm going to be using for uncaughtExceptions, unhandledRejections, and signals. And here, log as much as possible. I'm using console log for simplicity, but please use a proper logging library here. And pretty much if there is an error, and if that is an instance of the error, I want to get information about the message and the stack trace. And at the end, I'm going to be doing the graceful shutdown. So this is the same thing I explained before. I will close the server, and also I will have a timeout to also close the server after that timeout happens. So it depends, whatever ends first. And how to use this small module I have here. This is as an example. I have an HTTP server. I have my terminate code that I use for my project. I create an exit handler with the options, with the server I'm running, with the different parameters I want to pass into my exit handler, and I attach that function into the different events. So here, exit handler on an uncaughtException and an unhandledRejection, I'm going to return an exit code of 1, and I can add like a message to my logs to say what type of error or what type of handling was this, and also with the signals. And with the signals, I'm passing like an exit code of 0 because it is something that is going to be successful. So this is pretty much what I have for today in the presentation. Some resources that are going to be useful for you. Please don't miss Ruben Bridgewater workshop later today. It's going to be called Error Handling, Doing It Right. And he's going to be explaining now how to avoid getting here, how to avoid getting into the uncaughtException side of things, how to properly create error objects to have more visibility, how to handle promises, rejections. So these are going to be a very good presentation. And also the Cloud Native JS by Beth. She's going to be mentioning also how to add monitoring to your application, health checks. So those are going to be good things if you want to run Node.js properly in production. Some NPM modules to take a look that pretty much solves the issue I was talking about today. There is a module I like, the Terminus by the team at GoDaddy. It supports adding health checks to your application. It has signal handlers too. It has a very good graceful shutdown strategy, way more complex than the one I presented you. And this is something that you can add to your projects pretty easily. Just create an instance of Terminus, configure it, and add the different handlers there. There is also another module called Stoppable. Stoppable is a decorator over the server class that is going to be able to implement not the close function, but like a stop function. And it's going to be also doing a lot of things around graceful shutdown. And there is also a module that pretty much it's what I presented today. It's called HTTP graceful shutdown. You also pass an instance of your HTTP server, and it has like different handlers of you can like see what happened when there is an error, or what kind of signals I'm going to be monitoring. So pretty much these are going to be resources that are going to simplify your life and make you better at running Node in production, and you will be able to let it crash. One last thing, I want to invite you to NodeConf Colombia. So save the date. It's going to happen June 26 and 27, 2020. It's going to happen in Medellin, Colombia. More information at nodeconf.co. CFP is not open yet, but I will expect a lot of you all sending proposals to go to Medellin. We pay for travel, we pay for a hotel, and if you want to know a little bit about the experience of speaking at a conference in Colombia, you can ask James, you can ask Anna, and I think you can ask Brian. There is like a couple of folks here that have spoken there. And thank you very much. This is it.